Coding Samvad.
तो दोस्तों आज की प्रॉब्लम है मैक्सिमम सम पाथ इन टू एरेज। देखिए, इसमें हमें दो एरेज गिवन है। इनपुट को देखिए एग्जांपल वन को, और इसमें से हमें फाइंड करना है मैक्सिमम सम पाथ। और अकॉर्डिंग टू द क्वेश्चन, मैक्सिमम सम पाथ का मतलब है दैट वी नीड टू रीच फ्रॉम वन बिगिनिंग ऑफ एन एरे टू द एंड ऑफ द टू एरेज। एक एरे के स्टार्ट से दूसरे एरे के एंड तक चलना है, यानी कि फ्रॉम स्टार्ट टू बिगिनिंग वी नीड टू ट्रैवर्स इन सच अ वे कि जहां पर भी हमें एक कॉमन एलिमेंट मिले, वहां पर उस पॉइंट से हम ये डिसाइड करें कि एरे वन में जाना है या एरे टू में जाना है। ये डिसाइड किस बेसिस पर होगा? ये डिसाइड इस बेसिस पर होगा कि कौन सी एरे हमें मैक्सिमम सम देने वाली है, जिससे हम फाइंड करेंगे कि हमारा मैक्सिमम पाथ किस वे में बन रहा है। जिनको अभी भी कुछ डाउट है, चिंता मत करिए। अभी इसको और थोड़ा एनालिसिस करेंगे प्रॉब्लम का, और इस प्रॉब्लम को टू पॉइंटर अप्रोच से कैसे करना है उस बारे में जानेंगे। सो लेट्स मूव अहेड। स्क्रीन पर आप देख सकते हैं, इनपुट में हमें दो एरे गिवन है, एरे वन और एरे टू, और आउटपुट में हमें 35 मिल रहा है। तो अब समझना है कि 35 कैसे आ रहा है और कैसे हम इसको अचीव कर सकते हैं यूजिंग टू पॉइंटर। तो देखिए, एक पॉइंटर हम लेते हैं एरे वन के लिए, लेट से आई। एक पॉइंटर एरे टू के लिए लेते हैं, लेट से जी। अब चूंकि हमें सम पर खेलना है, तो कहीं ना कहीं हमें सम को भी मेंटेन कर रखना होगा, जो कि डायनेमिकली अपडेट होंगे विद सम कंडीशंस। सो लेट्स से दैट एरे वन का सम हम नाम करते हैं सम वन। इनिशियली इट इज आल्सो इनिशियलाइज्ड विद 0, as I is also initialized with 0, and similar to j is, and for this array 2 we will take sum 2 as 0. So I will be denoting array 1 with a1 and array 2 with a2. तो हमने जब ट्रैवर्सल स्टार्ट किया अपना एरे वन और एरे टू पर साइमल्टेनियसली वी विल स्टार्ट दी ट्रैवर्सल। तो हम ट्रैवर्स में चेक करेंगे, साइमल्टेनियसली हम ये चेक करेंगे दैट ए वन का जो भी एलिमेंट है उसकी वैल्यू क्या ए टू से कम है। अगर ये है तो फिर कुछ कंडीशन रही। So we will update our sum, that is sum equals to sum plus array of 1, and we will update it pointer. दूसरी कंडीशन ये रहेगी कि अगर array 1 of I is greater than a2, and this time we're going to consider this array, that is that we will update sum 2 with sum 2 plus a2 of j, and we will update j. And the last condition would be कि जहां पर हमारे पॉइंटर्स किसी ऐसी वैल्यू पर मीट करेंगे जो दोनों में कॉमन होंगे। फॉर नाउ वी कैन से लेट 7 विच इज कॉमन। तो इस केस को डील करने के लिए हमें एक वेरिएबल चाहिए होगा। लेट्स से दैट वेरिएबल इज रिजल्ट विच इज इनिशियलाइज विद 0, जिसमें हम इंक्लूड करेंगे अपना मैक्सिमम सम विद करंट आइटम। सो मैक्सिमम ऑफ सम 1 सम 2 प्लस द करंट वैल्यू ऑफ एंड प्लस दिस, और साथ ही अपडेट करेंगे अपने आई और जे पॉइंट। अभी सिर्फ एक ये रफ व्यू है, यू कैन टेक दिस एज जस्ट अ रफ एल्गोरिथम। ड्राई रन के बाद आपको एक बेटर अंडरस्टैंडिंग होगी, फिर उसकी हम और कॉम्प्लेक्सिटी में जाएंगे। तो चलिए स्टार्ट करते हैं ड्राई रन। तो चलिए स्टार्ट करते हैं ड्राई रन। इनिशियली आई जो है इज पॉइंटिंग टू 2 एंड जे इज पॉइंटिंग टू 1। also declare this condition as this is condition 1, this is condition 2, and this is condition 3। So according to condition 1, we will check that is 2 less than 1, which is false. So we will check now condition 2. So we will now check second condition. Is 2 greater than 1? And that's true. So according to second condition, I will update now sum 2. My sum 2 now will become the minimum, that is 1. Out of 2 and 1, the minimum is 1. So I have updated this one with sum. Now I will update this pointer j. So this j pointer will point to now 5. So now I will check that is 2 lesser than 5. Again I will check this. Again the flow will be same. I will be checking. So is this 2 is lesser than 5? And that's true. So I will update now my sum 1 as 2. And I will update this pointer of I. Now it will point to 3. So now I will check again that is your 3 lesser than 5, which is true. So I will update this sum 1 as 2 plus 3, that is 5. And I will update this pointer. Now it's pointing to 7. Now I will check is your 7 lesser than 5? Because still the j pointer is pointing to 7. So I have compared it with, and because still this j pointer is pointing to 5. So I have compared the 7 with 5, which is false. So condition 1 is false here. So I will now check for condition 2. Is 7 is greater than 5, which is true. That means I will update now my sum 2. Sum 2 now will become 1 plus 5, that is 6. And I will update my j pointer. Now j is pointing to 7 and I is also pointing to 7. So we are at a common point. Now we need to choose whether to move with array 1 or to move with array 2. So now we will check our third condition, and that is C3. So we will check our result now, that the previous result was 0. So it is 0. And the maximum of sum 1 and sum 2. So sum 1 is 5 and sum 2 is 6. So maximum is 6. And I will add the current element, that is 7. So it is equals to 13. 6 plus 7 plus 0. Now we need to note one thing here, that now since the result is 13 and we have got the sum 1 and sum 2 till the common point, that means we need to also update the sum value. So in third condition, we will also update sum 1 and sum 2. Sum 1 will be declared again as 0, initialize again at 0, and similarly sum 2 will be initialized again at again to 0. Let me make things more clear. So now the sum 1 is 0. Similarly, the sum 2 is also 0. So in third condition, we will now update both pointers. So now I is pointing to 10 and j is pointing to 8. So we will now compare again the condition C1. So we will compare is 10 lesser than 8, which is false. That means we need to compare C2. So I will compare now. The 10 is greater than 8, which is true. That means I will need to update my sum 2. So now sum 2 has become 8. And I will update the pointer j. So now j will come here. That is array 2 has been completely traversed. But in array 1, still the pointer is pointing to 10. That means still the two elements are left. So for dealing with such conditions where one of the array is still left to be traversed, since the other array has completely traversed, in that case, we will write one more condition, that is while your I is less than the size of array 1. That means the array 1 is still left to traverse. So we will be traversing this array and we will be updating all the left elements sum in either sum 1 or sum 2, depending upon the condition whether the array 1 is left to traverse or array 2 is left. Sum 1 equals to sum 1 plus array of I. And we will update the I point. Now this condition will also implies for array 2. For array 2, we need to change this I with j. Okay, let me write that also. So this I will be changed with j. That means this I will be changed with j. This sum 1 will be changed with 2. And this I will also be changed with j. And we will be here doing for array 2. So as I've said that we will be adding all the left element of the untraversed array to its sum. That means we will update sum 1 as 10 plus 11, which is equals to 21. So we are having sum 1 as 21 and sum 2 as 8 at the end. And currently the result is 30. That means after the whole traversal, that means whole traversal means that I have completely traversed array 1, I have completely traversed array 2. Nothing is left to traverse. What is left now? I am having my result, which is 30. I am having sum 1, that is 21. I am having sum 2, that is 8. So at the end, I will be finding this, updating this. Actually, I will be updating this result with result plus maximum of sum 1, sum 2. My result is currently 30 and maximum of sum 1 and sum 2. I'll be taking the maximum. So maximum is 21. And that's how I get the final as 35. Kindly note that by mistake I have written this element 11, but it was actually 12. It was actually 12. That means I need to update my sum 1 with instead of 11, it is I need to write 12. That means I will get here 22. That means sum 1 is actually 22. And this is how I will get at the end 35. Not an issue if you were focusing on 11, then you can assume that the output will be 34. तो चलिए अब समझते हैं इसका कोडिंग पार्ट. So we will be declaring our pointers, that is I and j. Let's initialize in 0 and we will be declaring our result where we will be storing the result that will return, and this sum 1 as 0, sum 2 as 0. I will be iterating over these array, but before that we need to also calculate the size of these arrays. Let's say n is the size of array 1 and n is the size of array 2. So we'll be iterating over these now. So we will be iterating till when these both conditions are satisfied. That means that we will be iterating over these arrays till we are having elements in the arrays. So if array 1 of I, that means the element of array 1 is lesser than the element of array 2, that means I will be considering sum 1. And I will be updating the index or the pointer of array 1 as if in case array 1 is greater than array 2, that means I will be updating my sum 2 with array 2 of j, and I will be updating the pointer j. In case I am reaching to the common element, in that case I will be updating my result. I will be considering the maximum of sum 1 and sum 2 with the current element on which the pointer is pointing. So let's consider that of array 1, though you can choose from array 2 as well. And I will be updating my sum 1 as 0 and sum 2 as 0. Also, we need to update the pointers here. Now, I will be writing the condition where one of the array is still left to traverse. So let me write for array 1. So I will be updating the sum 1 here. Now I will be writing for sum 2, that is array 2, where the array 2 is still left to traverse. So we have updated the j pointer. Now we have completely traversed the array and we are having the final result. Not the final result, we are having the final sum 1, sum 2 and the result. Now it's time to update our final result. So I will be choosing here the maximum of sum 1 or sum 2. And now I will be returning this result. So this is actually array of 2. And one thing that we need to note here, that in this question, the arrays are not sorted. That means we need to also sort these arrays. So let me sort the arrays. And arrays of sort array 2. So now let's submit this. All right, the code is successfully submitted now. तो दोस्तों, अगर ये वीडियो आपको पसंद आया तो वीडियो को लाइक करें, चैनल को सब्सक्राइब करें और कोडिंग संवाद के साथ बने रहें।
Like, comment, subscribe to Coding Samvad.